Welcome all to the next lab session of Generative AI. Myself, Madhu Nagaraj, Assistant Professor, Department of CSE Data Science. So the next program is the fifth program that is about using the word embeddings to create a meaningful sentences for creative task, retrieve the similar words for a seed word, create a sentence or a story using these words as a starting point. Write a program which takes a seed word, generates similar words, construct a short paragraph using these words. So basically what we are going to do is, so we are going to take one particular word, call it as a seed word, and then we are going to retrieve the similar words for that particular seed word. And then with the help of these similar words, that is semantically similar words, we are going to construct the sentences. And then with the help of all these sentences, we are going to create a short paragraph. So combining all these, we are going to form a short paragraph. So let's see how this program works. So starting with, so we are going to install the sentence transformers. So sentence transformers are mainly used to provide the sentence embeddings. So like we provide the word embeddings with the help of the transformers. So similarly, we are going to get the sentence embeddings by using the sentence transformers. So we are going to install the sentence transformers. Next, we are going to install LangChain Hugging Face. So like for in any of, for example, if you take any car, so it will be having an outer body, and then we are going to install the engine for that particular outer body and makes a car. Similarly here, this LangChain is like a framework and Hugging Face is a model. So we are going to integrate both the LangChain and the Hugging Face so that we can easily provide, so that we can easily get the details or we can easily get the services of this Hugging Face models. So we are installing LangChain Hugging Face together. Next, we are going to install the Keras. So Keras is mainly used to support the transformers. So whenever you want to display the values or display the details in the form of TensorFlow, so for that purpose, we are going to install the Keras. Next, we are going to import the Hugging Face hub. So Hugging Face hub is mainly, it is like a repository where it contains all the Hugging Face models present. So we are going to install the Hugging Face hub. Next, import the transformers. As I told, in order to provide the pre-trained NLP model, so we make use of the transformers. And then we are going to install the sentence transformer in order to load the sentence embeddings. So this is the sentence transformer which we are using, the model name All-Mini LM L6V2. So this is the model which mainly helps in the sentence transformers or the embeddings to get the embeddings of the sentences. So All-Mini LM V2. Next, we are going to print whether the model is loaded successfully or not. If at all there is any problem with this model, then we won't get this message. We will be getting the error. So once the model is successfully loaded, then we are going to get model loaded successfully. So again, we are going to install the sentence embeddings. So sorry, the sentence transformers. So import the sentence transformers. So from the sentence transformer, so whenever it is required for the embeddings, we are going to load it. So again, load the model. So this is the corpus which we are going to use in this program, which is related to the stock market, the financial, the banks, the stocks. So related to all those things, there are few sentences that are stored. So as you all know, corpus is nothing but a collection of sentences. So here are a set of sentences that are related to stock market. Next, what we are doing is, I'm passing this entire corpus into the model and I'm getting its embeddings. So the embedding for each of these sentences will be taken and it will be stored in the variable called as corpus embeddings. So this convert to tensor is mainly used so that the values will be displayed in the form of tensor flow and not in the form of arrays. So that is why we will make it convert to tensor is equal to true. So once I say corpus embedding, so you can see here all the embeddings of each of the sentences is stored. Now, once I get the embeddings of the corpus, now I'm going to define my statement or I'm going to define my function. So definition is the keyword, generate paragraph, and I'm passing the seed word. So I'm passing this particular corpus. So here I'm passing the corpus and the embeddings, what we got just now, even I'm passing that embeddings, the model, all mini LM V6, V2, and I'm telling I want the top 5 results. So this is my definition of the sentence. Next, what I'm doing, I'm giving a single sentence as a starting point, or you can say like a prompt. So where I'm telling, tell me more about the seed word in finance. So you can give any of the prompt related to your corpus. So for this corpus, I'm telling, tell me more about the seed word in finance. And that will be stored in the variable seed sentence. So once that is done, now I'm finding the embeddings of this particular sentence. So model encode, I'm passing this seed sentence and the embedding value of this sentence is stored in the seed embedding variable. Now, I'm using the PyTorch cosine similarity function in order to find the semantically similar words or references between this particular sentence and all the sentences in the corpus. So what we are passing? We are passing the seed embedding, that is the embedding of this particular sentence, and the corpus embeddings, the embeddings of the complete corpus. So these values. So both of them are passed and we are going to find out the cosine similarity between these two values. And 0 means we are going to start it from the first line. So we are specifying it with 0. So then it is going to fetch the top n results and store it in the top results variable. Now, I'm going to give the first line of my story. The topic of the seed word is crucial in the finance industry. So this is like the starting line of the story. Next, whatever the similar words I've got from here, I'm going to keep on add it with this particular line. So the sentences, similar sentences will be fetched from the corpus with respect to this particular sentence which I've given as the input, and all those lines will be added along with this particular line. So we are using the for loop and it is going to loop through each one of the line that is fetched and stored it in the top results, and it is going to add it into the variable story. So this is the first line. Later we are going to add one line after the other into the story, and finally I'm going to finish my story with this particular line. These concepts highlight the importance in understanding financial market and investment strategies. And say return the story. So here, everywhere we were just specifying the placeholder for the seed word. So never we mentioned which is the seed word. So now I'm going to mention that. So which is the seed word? Seed word means the bonds. I'm giving it as bonds. So you can specify any of the words that is related to that particular corpus. And I'm calling the function generate paragraph. So again, pass the seed word corpus, corpus embeddings, the model and top 5 values and print the story. So here you can see the story is printed. The topic of bonds is crucial in the finance industry. So this is the first line what we gave. The topic. So in the place of the placeholder seed word, now the bonds will be placed like this. Bonds is a crucial in the finance industry. Then all the 5 lines that is fetched from the corpus will be added. And finally, we are going to end it with the line that we have specified, this line. These concepts highlight the importance. So we are going to end it with that particular line. So this is how you are going to generate a paragraph or a story with help of a particular word called as a seed word and the corpus which we have. So by fetching all these values and adding it together, so we can form our own paragraph or the own story. Thank you.